Alright, so at 7.2, we're going to be finding the volume of certain shapes, and volumes can be found by breaking the shape up into representative discs or cylinders, really short, fat cylinders on their side. So you can see here we've got this region where we've been able to find the area by finding the area of a rectangle and then other rectangles, filling this region up and adding up the areas of all those rectangles as the width of the rectangles approaches infinity. So that's the integral. Well, what if we take that rectangle and we spin it around this axis down here? So it becomes something like this. So it becomes a disc, and this disc goes all the way through. So it's a whole bunch of discs or cylinders that are touching the axis of symmetry, but really are just a rectangle that's been rotated around and it fills in. And since we know we can find the area of a cylinder, which if we think about the cylinder being this way, it's the area of the base times the height of the cylinder. So this is the height, and then the base is circular, so the area of the base is pi r squared times h, and r is the distance from here to here. So if you flip it on its side like this, the radius is the distance from here to here, which is essentially just the height of the rectangle, this big capital R, that's the radius of the cylinder, and then this is the height of the cylinder, but since it's going in a horizontal direction, we usually call it the width. So the volume of one cylinder would be pi times, and then the radius squared, which would be the height of the rectangle, so the function, squared, and then times the width. So that'd be like the dx, or delta x. And then if we want to find the volume of this whole shape, not just one cylinder, we would add up an infinite number of cylinders that would all make a smooth curve here, like this. So what we're doing is integrating, adding up. Remember, integral means the sum of the limit as all these rectangles approach infinity, as the number of rectangles approach infinity. So we're going to find the integral of pi times the function squared times dx, and that will give us the volume of any solid that we've gotten from revolving a disc around, or a rectangle around an axis. Alright, so let's talk about that. If we've got a horizontal axis of revolution, then the height of the rectangle is the function, and we're going to integrate from a to b, so this left side to this right side, rotating around the axis. So when you draw these pictures, drawing the curve, shading the region that you're trying to rotate, remember sometimes finding the region is half the battle, and then draw a little arrow around the axis that you're revolving around, because it does make a big difference. This pi, remember, was inside here in the previous screen, but it is a constant, so it can come out. So it's pi times the integral from a to b of the radius, which is the function, top minus bottom, and the bottom is 0, so top minus bottom, we still do that idea, squared dx. If we have a vertical axis of revolution, then we're going to integrate with respect to y, and our rectangles are going to go right to left, so we're going to do right minus left. So the function is, the radius of the cylinder is the function, the right function minus the left function, squared, from c to d, from y value to y value. Again, pi is outside. Remember to use this disc method when the region that we're rotating is touching, like laying on the axis of revolution. Notice how this disc, once we rotate it, will not have any holes in the center of it, because the entire region is touching the axis of revolution, and so when we rotate it, it will create a cylinder without any hole in it. And in the future, next time we talk, it'll be, we'll talk about how to find volumes of solids of revolution where the region does not touch, doesn't lay on the axis of revolution. So then there will be a gap in the center, and that's going to be called the washer method, and you will have to know when to use which one. So be alert right now that all the problems that we're going to do, the region is totally laying on the axis of revolution. So when we rotate, there's no hole in the center. And that's when you use this formula, this disc method. Find the volume of the solid formed by revolving the region f of x equals square root of sine x and y equals 0 about the x-axis. So remember to graph the square root of sine x, and then draw a line around the axis that you're revolving around. Graph y equals 0, which is this, so we know that our region is only this region right here. Find your limits of integration, find the points of intersection, and we can do that by setting our function equal to the other function. Square both sides. And where does sine equal 0? On our unit circle, this is the ordered pair 1, 0, and there's sine, so we know 0 is one place, and this is negative 1, 0, and that's pi. So 0 to pi are the places where this graph intersects the graph of y equals 0. Our representative rectangles will always be perpendicular to our axis of revolution, just like when we were finding area, that the rectangles were perpendicular to the axis we were taking the integral with respect to. These rectangles have to be perpendicular to the axis of revolution to use the disc or washer method. So our radius is the function, which is square root of sine x. If you look at this picture, it gives you a solid of revolution. It's the end. It's what we're trying to find the volume of. It's kind of like a football shaped thing. So find the volume of this solid is what they're saying. But when you draw it, you can just draw this, and you don't have to try to draw the 3D image. So the volume formula is pi times the integral from a to b, so these are x values, 0 to pi, of the radius, top minus bottom, so square root of sine x minus 0, which I'm not going to write, squared, pi r squared, pi r squared. Remember when we were doing area, we didn't have squared, because we weren't rotating anything, we didn't have anything circular. So don't confuse volume with area. So pi r squared, pi times the function squared, dx. And then we can just integrate that. So we'll simplify, square root of sine x squared is sine x, and the integral of sine is negative cosine. So we have negative pi cosine x from 0 to pi. Cosine of pi minus cosine of 0. Cosine of pi is negative 1. Cosine of 0 is 1. So we have negative 2 times negative pi, which is 2 pi. So the volume of this region is 2 pi. Find the volume of a solid formed by revolving the region bounded by 2 minus x squared. So this function would go on here and here, 2 minus x squared, and g of x equals 1. So here's g of x equals 1, and that's the region that we're trying to find the volume of. That's going to be revolved around the line y equals 1. Thus we have this little arrow going around that line. Notice our region is laying totally on the axis that we're revolving around. So when we spin our representative rectangle, it will make a complete filled-in cylinder. Our height, or our radius, the height of the rectangle, which represents the radius of the cylinder, is the top of it is laying on the curve 2 minus x squared, and the bottom is on the curve 1. So we still have to do the top minus bottom idea. So our volume is going to be the integral of the top function, which is 2 minus x squared, minus the bottom function, and that whole thing gets squared. Okay, because it's top minus bottom, that represents the radius of our cylinder, and that whole thing is going to be squared. And our numbers over here that we have to find, 2 minus x squared equals 1 where? So let's add x squared and subtract 1. Take the square root and we get positive and negative 1. So our limits of integration are negative 1 and 1. And so we can simplify this inside of here. We have pi times the integral from negative 1 to 1 of negative x squared plus 1, and that's going to be squared. I don't have a rule to integrate a chain, like a composite function. I don't have a chain rule for integration, so I am going to square it. So you get positive x to the 4th minus 2x squared plus 1. That's been squared now. So now I can integrate it. X to the 5th. Add 1 to the exponent, divide by the new exponent, x to the 5th minus 2x cubed over 3 plus x from negative 1 to 1 and that's all times pi. And I'll let you guys finish that off. It's going to end up to be 16 pi over 15. So it's top function minus bottom function, all right? Find the volume of the region bounded by y equals x. So there's y equals x equals 3, here's x equals 3, x equals 0, here's x equals 0, and y equals 3. So what's the region? Y equals x equals 3, x equals 0, and y equals 3. Essentially, this x equals 3 line isn't important in this example. And we're revolving it around the line y equals 3. So the x equals 3 line didn't matter in this example. We want to find that volume, and we're going to, our rectangle will always be perpendicular to the axis of revolution. But notice that the radius, or the disk, is below the region that we're rotating it around. It's still top minus bottom. So top is 3, bottom is x, and we square that. And our limits of integration are 0 to 3 with respect to x. All right? Now what if I wanted to change that? That's just the setup. I'm assuming you guys could finish that up. What if I wanted to change that and revolve it around the line x equals 0? So I'm revolving it around this. What's going to change? Well, my rectangle is now going to go this way. I'm going to do right minus left. So I'm going to have the volume equals pi times the integral. I need these to be y values, which happen to be 0 to 3 again. And I need right minus left with respect to y. So what's the equation of this? Well, it's already solved for x and y. But if this were more complicated, you'd have to solve it for x and get the function on the right, and then minus 0, and then square it with respect to y. So that one would actually be easier to do because I wouldn't have to square out this to integrate it. In the next couple of lessons, we're going to be talking about how to rotate a region like this around a different line. Like, what about this line, or this line, where our region is not laying on the axis that we're revolving around. How about this? Find the volume of the region bounded by y equals 4, that's this line, x equals 4, that's this line, y equals x squared, that's this line, and y equals 0. So it's a strange little region. It's actually this region here. So don't always assume it's inside of the function. It could be next to the function. And we're revolving around the line x equals 4. Notice that the region we're revolving is laying on the axis that we're revolving around. So let's set that up. If we're revolving around an axis that's vertical, our representative rectangles are horizontal. Again, we do right minus left. So it's pi times the integral of the right function, which is 4, minus the left function. Now I need to solve this function to be in terms of x. So I'm going to take the square root of both sides, and that equals positive and negative square root of y. This would be the negative one, and this would be the positive one. So positive square root of y. Square that because it's a radius. And our limits of integration are from 0 to 4 with respect to y. So there's the setup for that. So we're still doing right minus left, or top minus bottom. And then we just square the region because that represents the volume. Okay, there's your homework. It looks kind of pokey because I cut out all the ones where the regions were not touching the axis of revolution. So it's 1, 3, 7, 9, 19, and then 23 to 41 odd, but in that group skip 29, and then do 49 and 51. Have a good rest of your weekend.